Well, happy Thursday, everybody. Thank you for completing your STAR assessment yesterday. And if you're out there listening and forgot to do it or didn't do it, please accomplish that today, in addition to the lesson that we're going to do right now. So, as you see this slide, it's called Types of Solutions, and it is a Freyer model. And so, what I would like each of you to do right now is to pause the video and in your notebook, copy down this Freyer model with types of solutions in the middle. And then I want you to record in the three scenarios in the three different blocks that they are in. Okay, so go ahead and do that now. I'm going to pause briefly while you do that, and you can pause as well and resume the video once you have the three scenarios written down. All right, welcome back. So, what we're going to do is start with the first one that says Green's Gym charges a one time $50 fee and a $30 per session for a personal trainer. Magenta Fitness charges a $250 membership fee and $10 per session for a personal trainer. After how many sessions will the cost for a personal trainer be the same? So, what we're looking at here is we're going to write an equation that explains this situation or models the situation. So, we have one fitness center that has a $50 flat fee and charges $30 per session. And then our other fitness center has a $250 flat fee and charges $10 per session. So the question is, when do they charge the same amount, which is why we insert the equal sign. So as always, I'll move my variable to one side of the equation. So I move the smaller to the larger. So that gives me 50 plus 20x equals 250. Then I subtract 50 from both sides. That leaves me with 20x equals 200. Divide both sides by 20, and x equals 10. So what x equals 10 means to me is that after 10 sessions, the cost for each personal trainer will be the same. So this is the type of equation that you have been working with so far, and this is what we call a one solution equation because it only has one answer, x equals 10. That is the only value for x that will make this a true statement and a true equation. Okay? So let's look at the next one. It says Cletus owns a tree farm and raises Douglas fir trees, one of the most common trees purchased for the family Christmas tree. He plants two saplings in the ground and records their growth over time. One sapling was 3 feet tall when it was planted and grows at a rate of 2 feet per month. The other sapling was 5 feet tall when it was planted and grows at a rate of 2 feet per month. Cletus wonders if the two trees will ever be the same height at the same time. Will the two trees ever be the same height at the same time? So what we're going to do again is we're going to write an equation to model this situation. So we had one tree that started at 3 feet high and was growing at 2 feet per month. The other tree started at 5 feet high and was growing at 2 feet per month as well. And Cletus wants to know when they're going to be the same, so we insert an equal symbol here. So, like I always do when I'm solving an equation, I combine my variables or move them to one side of the equation. So 2x minus 2x is 0, 2x minus 2x is 0. So that leaves me here 3 equals 5. 3 equals 5 is not a true statement. So whenever we find ourselves in a situation where an equation produces something that is not a true statement, we call this a no solution equation. All right, this is a no solution equation. So when we go back to Cletus then, what we're going to say is this one here is no solution. And what it means is the two trees will never be the same height at the same time. Now let's look at our third example. The third example says, at what value of x will the following shapes have the same perimeter? So if you look at the triangle, it is an equilateral triangle. And just by way of remembrance, when those lines are through each side, it means those sides are congruent. So if one side is 4x plus 8, all sides have to be 4x plus 8. And then the other shape is a square, which is 3x plus 6. And we should know that a square has sides that are all equal or all the same. Okay? So when we come over here, now the measurement for my triangle was 4x plus 8. So perimeter is simply adding up all sides. So we could do it this way and get an answer of 12x plus 24. Or, since I'm in Math 1, I'm going to do it the algebraic way. So I have three sides, and each side has a measurement of 4x plus 8. So I'm going to write an equation that says 3 times 4x plus 8, because all multiplication is a faster way to do addition. Likewise for the square, my square has 4 sides, and those 4 sides all measure 3x plus 6. So rather than adding 3x plus 6 4 times, I'm going to say 4 times 3x plus 6. Now I'm going to just solve the equation for that value of x. All right, so after I distribute, next thing I do is move my variable from one side of the equation to the other. So when I do 12x minus 12x, that gives me a 0. So I bring down the 24. 12x minus 12x is another 0, so I bring down the 24. And I have the same thing on both sides. So what this is called, when I see a solution that looks like this is called an identity, because they look the same on both sides of the equation. So it's an identity, identical. Infinitely many. And what infinitely many means is that there's more than one solution. So the value for x here, and you could certainly do this on your own, you could substitute 1, 2, 3, 4, or 5, any of the numbers that are all the real numbers could be substituted into this equation, and it's still going to be a true statement. Okay? So whenever you see something that looks like this on the bottom line, it's an identity. It looks the same on both sides. Infinitely many, because there can be more than one solution. All the real numbers could be a solution to this particular equation. So I'll simply move this over here. And so what this means, it says at what value of x will the following shapes have the same perimeter? Basically, any value of x or the values of x that are in the real number system. All right, so hopefully at home you completed this with me. And this is how it would look at the end once you've completed it with me. Okay, now what you're going to do for your assignment today is on Canvas. It's called Types of Solutions Thursday, which you're already in and watching this video. And after you watch the video, there's a total of 13 problems to complete. So for the first 5, you're simply going to do the math for those equations. And then it says here to solve each equation and state whether it has one, infinite, or no solutions. And if it's just one solution, solve for the variable. Okay? Then the next part says to write an equation that models each scenario, then solve the equation, state whether each equation has one, infinite, or no solutions, and provide an answer to the question. So look at the example. The example says Benji buys a laser tag pass for a $4 fee and will pay $3.50 per game at Laser Plaza. Lisa buys a laser tag pass at $5 and will pay $3.50 per game at Laser City. How many games will they have to play to pay the same amount? So as you see here, the equation was set up explaining Benji and Lisa. And then we did the math, and 4 equals 5. That's no solution. They will never pay the same amount. Okay? So this is how all of your answers should look. I should see an equation. I should see an answer. I should see either no solution, one solution, or infinitely many solutions. And I should see a statement such as they will never pay the same amount or whatever explains your scenario. All right, so there are 2 slides. This is slide 1, and this here is slide number 2. So you should do a total of 13 problems. All right, so if you have any questions, I will be on Google Meet